Hi everyone, welcome to Lenovo's Hackathon workshop. My name is Retric and I'm a developer at Duktape. Today I want to talk about the interoperability of Lenovo's blockchains. We do think that this is a very important topic because we believe in the near future we are going into a sort of multi-chain metaverse crypto new world. There will be many different blockchains surrounded by many different developer ecosystem, and they were growing many different applications on top of it, and of course extracting many different users. And to make this kind of future happen, the first and maybe most important problem we want to solve is that how do you make all these different blockchains to communicate with each other, interact with each other. How do you make people transfer their digital assets from one chain to another, or even call smart contracts from different blockchains? And how do you provide a better user experience where the end user don't have to worry anything when they are switching between different blockchains, or they even didn't notice that they are on different blockchains? How do you make a developer migrate their application into different blockchains? And how do you make user with different wallets and tools to access these applications? It is like you are using iPhone and I'm using Xiaomi or Google phone. The phones and the mobile operating systems from iOS and Android are very different, but we can still communicate with each other. My apps can talk to your apps, and even they lived in different platforms. This is what we mean when we talk about interoperabilities of blockchains. The word interoperability itself is a little bit hard to understand at first glance, but from a high-level perspective, it is a pretty simple vision. And in order to fulfill these simple visions, we have seen many attempts, many different solutions trying to solve this problem. Some of that attempts might be wrong and some might be right. For example, we think that simply setting up another new standard, trying to make everyone to follow this new standard can do little help to address the interoperability issues. A lot of blockchain protocol emerged, and the protocol are not compatible with each other. So instead of connecting different chains, they sort of building a new world and became its own digital gardens. And the right solution, we believe, is to require one chain to be able to run from the other chains to really understand different chains. It is like you speak French and I speak Chinese and Tom or Jerry speak Japanese. We can't talk to each other because the language. And to solve this problem, some people came out with the idea like inventing another new language and sell this new language to everyone. They are trying to make you and me and Tom or Jerry to speak this new language. And if we want to have a nice conversations, the four people of us have to learn another new language. And it is always hard to learn a new language, right? But the more serious issue is that we not only needs to learn a new language, we have to also agree to learn the same one. We don't have English here. Instead, we got language A, language B, language C, and they all claim that they are the English. But you never know. Maybe the crypto world just doesn't have a English language at all. So to continue with this metaverse, the solution from Lenovo is like to have a super translator. Let's call her Lena. Lena might speak one language, but the superpower is that Lena is very smart and she can study different language. So she can learn from you to speak French, and she can learn from me to speak Chinese. Lena can be our translator. We don't have to do anything in order to have a conversations. If there is a new guy speaking a new language and he wants to join our conversations, then I can adapt and learn this new language too. So basically, this is how Lenovo is trying to solve the interoperability problems. And it is just a metaverse. So technically, how do you want Chain to be like Lena, the super translator? What does the ability to learn from other blockchain look like? It is a complicated answer. Maybe we can start from small examples. So right now we have a EVM compatible layer called Polyjuice integrated with Galwakan, which is a LoRa framework on CKB. And I like to take this EVM compatible layer as a first example to showcase how the interoperability of a nervous network works. I know some of you guys may be thinking that there are already too many EVM compatible chain or layer 2 solutions. Why do I need to care about Polyjuice? I like to point out that a lot of EVM compatible chain are originally forked from Ethereum with a few changes. So basically they are almost the same things. On the other hand, CKB is a unique and special blockchain. We use cell model, which is like a more generalized UTX model from Bitcoin, and very different from a car model, the one that Ethereum is using. So even CKB is much different from Ethereum. We are still able to build Polyjuice as a compatible layer. I think that is a pretty good example to show the potential of the interoperability for nervous network. And the Galwakan Polyjuice is not only about being compatible with EVM, it has some other even cooler features, but I will talk more about this later. So how does Polyjuice works really? Because it is built inside Galwakan, so firstly you need to understand how Galwakan works. Galwakan is a generalized LoRa framework on CKB. Right now we have implemented the Optimus rollup. Later we might have JK rollup as well. We all know that rollup is a very popular layer 2 solution on the industry right now, and there are also some projects on Ethereum too. A rollup works by having a bunch of aggregators to constantly collecting layer 2 transactions, and they submit those transactions to layer 1 blockchain. You can become aggregators by staking some token on chain. It is permissionless. When submitting the layer 2 transaction are not already stored on chain. Instead, we use a special data structure called sparse mercury to update the status with specific transactions. The sparse mercury stores the global status on the Merkle so that even layer 2 transactions are growing and there are more and more layer 2 transactions, we only have to store the Merkle on chain. Thus, we can save a lot of space on chain. So what if a bad person submit a bad transaction and the Merkle status goes wrong? There is a mechanism called challenges, where you can challenge the specific transaction and prove that the Merkle is wrong. Once challenge succeeds, you can claim the staking funds from aggregator as a prize, and it is also a punishment for aggregator. So this is a basic idea about how rollup works. And the interesting thing to build rollup on top of CKB is that we also implement a simple account layer in Godwalker rollup. The UTXO model and the account model are very different. They both have some upside and downsides. For example, the UTXO model is quite flexible and is better at doing parallel jobs, but it is hard to deal with when you have some status sharing needs. On the other hand, the account model did not have the status sharing issues, but it has to process a sequence. But to be clear, both UTXO and account model are equal, referring to the ability of expressions, meaning that what programs you can build upon account models, you should be able to build the same programs on UTX model as well. It is more like a different approach, a different program mindset. Underneath Godwalker, CKB is using cell model, which is generalized UTXO models. In Bitcoin, UTXO can only store how much money you have, and we extend the UTXO to a more generalized structure. You can store arbitrary data like a string, an article, even some code. And actually, this is exactly how smart contract on CKB works. We just store the code on a specific cell, and the code can be rolled from there and execute and run inside CKB virtual machine called CKB VM. The cell model is very powerful and flexible. The blockchain CKB is also designed to be highly flexible and maximize abstraction. For example, we have account abstractions where you can implement your own account unlock method. If you don't want to use the CKB's default Black 2B SEC 256K1 authentications, you can just implement your own one. And also we support custom cryptographic primitives. And a system like Ethereum, the cryptographic primitives are limited to a small range of choice because they precompile those whitelist algos in EVM. Here on CKB, the system default cryptographic primitives and a custom one both live in the same environments, meaning that they have the same priorities. There is nothing special for the system default one. And that's the reason why you can see some community projects like PWLog only emerged from CKB blockchains, not from other chain. It is built on top of this very simple yet powerful abstraction layer 1. Using PWLog, you can use Ethereum or other blockchains wallets to receive and send CKB token. So even a cell model is very powerful and simple, but sometimes it is just too flexible for a developer to really build a simple dApp. Because the program mindset for UTXO is very, very different from account models. And since Ethereum is the most popular blockchain with smart contracts right now, developers are almost adapting to this account model mindset. By implement a simple account model layer on Godwalker rollup framework, we can leverage the flexible CKB blockchain while providing a generalized layer 2 account model program interface for developers to help learn migrate layer depths or building a new one using the same skills they got from Ethereum developers' experience. And finally from here, we can start talking about how Polyjuice really works. So in Gawakan, we have two kinds of accounts. It is very much like Ethereum. One is EOA account, which is owned by the user, and the other one is contract account, which is owned by the pieces of code. And the difference part is that for the EOA account, we can have different account lock. So you can use Ethereum signature algorithms to manage your EOA account. You can also use other blockchain signature algorithms. For example, we have implement Tron account lock too, so you can use that to protect your account as well. The reason Gawakan can do this is because the underlying CKB blockchain is flexible and abstraction enough to support custom cryptographic primitives like we mentioned before. And since we got different account lock on Gawakan, we can even use Tron wallet to interact with the smart contract deployed on Polyjuice. We can build a real universal dApp now, because when we are building a dApp on Ethereum, mostly you are limited to the Ethereum's users. But once you migrate the dApp from Ethereum to Gawakan Polyjuice, you can make Tron wallet users to access this dApp as well. That's another interoperability for Gawakan. And actually, we have an example to teach you how to do that. You can check out here. It teaches you step by step how to use a Tron wallet to execute a smart contract call. And for another account, which is a contract account, it can be loaded from different backend, which defines a very specific process logic. Take Polyjuice as an example. The Polyjuice is a backend for Gawakan, and the Polyjuice defines the process logic to be like Ethereum, so that it can be compatible with EVM. The reason that Polyjuice can define such a logic is because we have integrated EVM instance inside Polyjuice, so that for a contract account, if it is using Polyjuice as backend, every time we receive a new transaction, a new Polyjuice transaction, we will feed the transaction to the EVM instance inside Polyjuice and load the smart contract code from this contract account into the EVM instance, and to make the EVM instance to execute the transaction and then return the output data. And if you want to even dig more deep and asking why can Gawakan integrated a EVM, it is because in CKB blockchain we have a very generalized and powerful virtual machine called CKB VM, and CKB VM did not contain any pre-compiles compared to Ethereum EVM, so it is also a very clean one. Because of this powerful and abstract enough virtual machine, we can leverage CKB VM to run another VM. So we are literally just running another VM inside CKB VM. And once we integrated EVM inside Gawakan Polyjuice, every time we produce an output on layer 2, the underlying layer 1 CKB blockchain can also be executing the very same logics and verify if the output is valid on layer 1 on-chain. And yes, maybe this PPT can better explain the idea. So here we have two pieces of code. One is called generator and the other one is called validator. Together, these two pairs of code just compose as the produce backend for GuardWorken. They are almost using the same code. So basically, generator is almost like the same with validators. The difference part is that generator is supposed to be running off-chain, and it will prepare a GuardWorken transaction based on EVM executions, and the validator is supposed to be running on-chain. So when a produce transaction is submitting on-chain, the validator can validate the same VM logics and make sure that all state updates are valid. And the best thing about this model is that it really decouples with the underlying virtual machine, which meaning you can integrate EVM to produce, but also you can integrate another VM like JavaScript VM or the Mu language virtual machine, also the other VM to sort of become another new backend, and it all works in the same way like produce. With this design, we can implement a lot of different backends to be compatible with a lot of different blockchains. This is like the super translator Nena, remember? Who can learn and speak so many different languages. And when I say we need a new way to really understand our blockchain, to learn from our chains earlier in this video, this is what I really meant technically. It's to have a new way of mimic the other blockchain's behavior to sort of simulate other blockchain's actions. Therefore, we are natural to address the interoperability problems. But as the saying goes, talk is cheap, show me the code. I do have prepared a very small example to demonstrate how this interoperability looks like besides produce. And here is the simple idea. What if we really integrated a JavaScript virtual machine to just replace the EVM inside produce, and we keep everything else unchanged, meaning that the Ethereum transaction structure and a bunch of other things won't change, so we can reuse some code, and therefore we have a new Ethereum chain running on layer 2, but with a very different virtual machine that can be executing just bytecode. From here, we can sort of introduce a new version of Ethereum. The smart contract is no longer written in Solidity, but in pure JavaScript code. I choose Duktape as the JavaScript VM to integrate it into produce, and let's try if we can use this to write a simple smart contract and even interacting with this smart contract. So right now we're going to write we're going to write a smart contract with pure JavaScript, and this is the one. You can see it's a pretty simple one. Here we define a global variable called store data, and we also define two simple functions, which the first one is called set. He just set a value to this store data global variable, and the second function is called get. It just returns the store data's value, and it's very simple, right? And right now we are going to try if we can deploy this smart contract written in pure JavaScript to our Gaussian produce. So we this simple tool to encode the smart contract, and let's just say and we use and we click deploy contract and select the one that store our bytecode, and make sure that our Gaussian is already running, and this logs showing that Gaussian is producing new blocks and everything was fine. So let's just click. So here the MetaMask is asking me to sign a transaction message, and this transaction will deploy our JS smart contract bytecode onto the Gaussian produce, and we can see like the log is successful, and we can see from the logs that when this transaction come in, here it just run with the our Duktape virtual machine instead of the EVM machine, because we have replaced the virtual machine inside produce. So here we can see that this inside Duktape we make the contract code stored on Gaussian produce, and then just replace our contract address using the same algorithm for produce. And now let's using this contract address to try if we can really interacting with this smart contract. And we can use this simple HTML page as interface to interact with our smart contract. So here because we just replace the EVM with our Duktape virtual machine, and we keep the other part of Polyjuice unchanged, so we can still reuse the code to call Polyjuice. So here we use Web3.js to send a transaction, and for these transactions we let's just replace these two address to our newly deployed one. So replace with this new address. And for the data part, so as you may know that Ethereum has its own like function signatures. The first 4 bytes will be the function signatures you want to call with. And here we implement another simple encoding method. We just put the function name you want to call on the first 4 bytes in this data path. And the encoding method is really simple too. So the function we want to call is set, so we just convert this set and using this value to sort of replace the 4 bytes. So for last 4 bytes we will like treat it as an area to like put our parameter for this specific function. So here the parameter value is 8. So the data is meaning like we want to call the smart contract function set function with a value 8. And let's try if we can like interact with our smart contract successfully. So and let's just try. The MetaMask also asking us for sending a transaction messages. And let's see the logs of, yeah, it's already here. So you can see that we have the message input. This data is the same as this one, and the Duktape virtual machine just load the smart contract code, and he extract the name from the input data, the first 4 bytes, and he knows that is calling a set function, right? And the parameter is 8. Yeah, it's all correct with our parameter here. So the Duktape virtual machine should execute the code the way we want. Let's just try calling another function. So here we have another. Let's look at the smart contract we write. Yeah, here. So another function is called get. It will return the stored data value, and here we use the same method to construct a transaction and to send these transactions. Let's just say transaction hash, and the contract address is changed to the right value. And the data part here, you can see that it's get. So use this simple encoding method, and and it is first 4 bytes, so let's just fill up the last bytes, and it means to call the get functions. And because this function doesn't have like a parameter, so it just has the first 4 bytes. And we try, let's try to call this get functions. Here, get. Get. Yeah, in the, let's look at the logs. This time, the Duktape virtual machine extract method name from input data, and the name of method is get. Yeah, in the SQ result is 8, right? In the 8 is the value that we first set in the first transactions. So we can try another one to check if indeed like working as we want. Let's say a function like 28, but it is in this is 17 in hex value, right? And let's reload and call again. Let's read the logs. Yeah, here set method, and the parameter is 17. It is right because 11's hex string is 17 in decimal. So let's call another get. And let's read the logs. Oh, okay, so here the Duktape version just execute the get function, and the result is 17. Yeah, 17. So yes, I think everything was work as we expected. So the JavaScript smart contract is really working in our Polyjuice examples. So it works, and if our Galwakan can work with this newly created JavaScript VM backend, it can add another backend in order to be compatible with our newborn blockchain as well. It is like a new person wants to join the conversations, and Nina just stand out and learn the language to open the door for him. Okay, so that's it. I hope these short videos, this little workshop, can show you the idea about how interoperability works on CKB, Galwakan, or even make you interested to try our tech. Since the CKB is designed to be highly flexible and configurable, we really want Galwakan to be a fun toy too that you want to play with. Don't just migrate an Ethereum dApps to produce. Galwakan is more than that. Go and find out its potentials and most importantly, have fun coding. I will leave this picture as an ending to this talk. Maybe it will explain the interoperability idea better than me. See you next time.